Greetings, Andy Dukes here. Welcome to Ride and Talk, episode 10. We're bringing you this podcast from a restricted location in the south of France. We're at the Autodrome de Miramas test site, not a million miles away from Marseille. It's BMW's proving ground, and it's here where the bikes and cars we're going to be riding and driving in the future are put through intensive test cycles. It's an amazing place, as you can hear in the background from all of the different engine noises. A variety of test tracks for all kinds of BMW vehicles have been created here. There's more than 50 kilometres of conceivable driving scenarios that can be simulated, including motorways, twisty roads, racetracks, wet conditions and even tough off-road challenges. From a motorcycling perspective, around 180 BMW bikes are tested to limits here every year, with a staggering 3 million kilometres covered in total. There's so much more happening at Miramas than just riding, however. Everything is done with a view to the future, so new solutions and technologies are put to the test inside the development centres, on track and at test areas under the most demanding of conditions. Ultimately, it's all about low data acquisition, component validation with laboratory test rigs, and vehicle validation with extensive endurance testing programs, the like of which you can hear happening all around me right now. The targets here are mechanical, electrical and functional validation, all leading to confirmation of vehicle quality and ultimately to customer satisfaction. As you're going to find out, BMW Motorrad has a very systematic approach to vehicle testing. As such, around 30 journalists from across the globe flew in at the end of November for a special tech day to find out exactly what goes on behind the scenes at Miramas. Here to tell us more is Jens Stäbe.
My name is Jens Stäbe, and I'm responsible for the development of the total vehicle. Total vehicle means we are creating the concepts, doing the architecture of all the bikes, building the prototypes, the virtual bikes, and also real bikes for riding. We are doing the endurance testing and validation, and also the homologation at the end, and involved over the whole development process. Miramas is a very important facility for us because we can ride here all year long. We have no break in the wintertime like in Germany. It's a very huge testing facility here. We have 5 square kilometers size and have all roads you can imagine here, like handling tracks. We have a race track. And we have a very special Autobahn ring. It's you can drive maximum speed how long you want.
So with all of these different test configurations, you can pretty much replicate any situation that you would find on the road, on the street, or even off-road.
If you ride here in Miramas, it's you will ride all over the world. But our aim is to understand our customers in detail, how they're riding, and so that we make the design of the bikes exactly according to the needs of the customers and the expectations. And then we will have lucky customers, and that's quality.
There isn't anyone who knows more about the relationship between a BMW bike and a road than Rudi Schrupp. He's been working on load prediction data for more than 3 decades. You might not know exactly what happens to your whole bike when you ride into a pothole by mistake, or what stressors are put on your wheels by hitting a speed bump at the wrong speed. But he sure does. Listen up.
My name is Rudi Schrupp. I'm at the BMW company all in all 35 years, and 30 years of that is just being at the motorcycle department. I started at the motorcycle department with the job I'm still doing, that means load data measurement. So it's 30 years of experience.
So why do you need to measure the forces that happen to a bike on the road?
Because you have to go on a test bench with those data to see whether the bike will withstand this load without breaking, without any damage. So you can't go on a road and test until the bike breaks down. That will be much too dangerous. You have to go to the test rig. On the test rig, you get those data which we are measuring on the bike into the test rig, and this test rig is running day and night for 2 or 3 weeks, and afterwards we know whether the structure is okay or not.
And how many different load points can you measure on a bike?
At that bike at the moment, I think we have 200 signals.
Okay, so this is an R1200 GS. How can you replicate riding situations all over the world then?
Normally we get in contact with the dealers in those countries, and they tell us we have some riders. We will be the tough riders. This rider will be for you, and I'm going down to this country to South Africa or Brazil for 2 or 3 weeks or longer, and then we'll do a lot of measurements, a couple of thousand kilometers, measuring all conditions from town to road to off-road. So we try to get all those different situations which are specific for the countries.
So this R1200 GS that we're looking at now, where's it been and how has it been ridden across the world?
This is quite a GS from Berlin. We changed all the electronics in it at Munich, and then this was my trip companion to Brazil, South Africa, Mongolia, all over Europe. And next stop will be India.
And it's even been in the GS Trophy?
Yes. Not in the trophy itself, not at the competition, but 2 weeks before when the officials made an inspection tour on the trophy.
During the Marshall Scouting?
Yes, we did the complete Marshall Scouting with this GS, completely from start to end.
What's the value of equipment on this GS that I'm looking at right now?
The value of the equipment is about 300,000 euros, and the labor which is put in this bike is 200,000 euros. All in all, is a half million euros in this bike.
€500,000. So I'm looking at the wheels here. What can you tell me about these particular wheels?
These wheels measure everything which happens between road and bike. Every force which happens between riding on all conditions.
And what are these wheels made out of, and where are they made?
There's a compound structure between aluminium, titan and carbon. This is a fourth generation. The first generation was made by BMW itself. We had a patent on this for 20 years, and now we have someone doing this technique for us.
So can you tell me at which different points on this bike you're measuring data?
We start from the road. That means we are measuring everything between the road and the bike. These are the measuring wheels. They look like special wheels, but not too much different from normal wheels. And then we go into detail. That means we are measuring any kind of force or flexion in the bike, which is perhaps the fork, the bending of the fork, the forces in the spring, the forces in the swing arm pivot, the forces in the swing arm, the forces in the rod of the damper, everything which is of interest in a bike. We can measure in Newton, in kilograms, what is happening, or in kind of acceleration, how many G's is working on the structure.
Thanks, Rudy. We talk about good vibrations with our iconic Boxer engines, for example. But what about bad vibrations? How do you measure these across various parts, brackets, nuts and bolts, and then decide which parts to accept, reject or modify for future models? Here to tell us more about this is Jörg Schuller. Think about him next time you test your subframe's specified limits by completely overloading your panniers.
My name is Jörg Schuller. I'm the guy who is responsible for NVH testing, noise, vibration, harshness. Mostly it's vibration. Harshness is a result. Vibration is what we measure and what we test in riding.
So why do you need to measure noise and vibration? Why do you need to collect this data?
First, the part that's easy to understand is everybody can feel vibration. As I said, up to about 250 hertz. Then you stop feeling it. Your skin starts to, I don't know, not indicating it anymore. But we needed to know, let's say, especially for electronics, but for a lot of parts everything is getting lighter, everything is getting stiffer. So vibration, mostly caused by the engine, find their way through the chassis. As everything is light and stiff, and a lot of electronics, we have to look what has happened to the vibration along this way, because it can be destructive for the parts, for a lot of parts.
Basically, just because we can't feel it anymore on our bodies, it doesn't mean it's not happening, right?
Absolutely.
So how many different points are you measuring at, and where are they on the bike?
Up to, I would say, 160, and it's everything you can imagine. I mean, in the end, it's always a path from the start of the vibrations, which is usually the engine, and then the transfer of the vibration into the part that we are looking at. So from here we had to get a steering head, you get a steering head, you get maybe the engine mount, you get the engine itself. So from there, it's just 7, 8, I don't know, I didn't count it, that you have just for the right handlebar. A TFT display full of electronics. Oh my God, you have to measure it. You have to measure the input, so the mounting part, and you have to measure the part itself on different points. Mirrors, something that is very important for the sight. So this is vibrations you can feel and see, but of course we have to check them. So we check measuring and we check riding. Same for the rider contact points.
So what's the value of this system?
The value of the system, oh my God. At the bench, I would say the measurement system alone is 250,000. It's just a computer, but it's big. Each of the sensors, little sensors, 7 millimeter square, 1,700 euros, 1,800 euros. And then, of course, the software is like always. It's very expensive. The logger itself is 50,000.
How did you get into this world? What were you doing before? I imagine you were working. I imagine you're a very good rider.
I wouldn't say very good. There's better ones. I was a hobby racer years and years ago. I'm an engineer, but I started maybe like you at a magazine. I was a test rider for a magazine for Motorrad and PS. Then I went to. I was at a bicycle magazine because I love mountain biking. Wonderful. And there I started measuring. A little with the motorcycle magazine, but it was too early. But there we started measuring what is happening, what is going around with 2D systems back then. Then I went into IDM, with the German Championship, as a race data guy, and chassis engineer. Oh, what did I then? A different competitor for 7 years as a product manager, and now I'm at BMW. So it's motorcycle world. It's a big world. There's a lot of opportunities.
And I imagine you have no shortage of wannabe test riders lining up to help you out here.
Of course, because it is. I mean, as we all know, testing it can be the one opinion of one guy, but one guy is very subjective. So we should have much better riders, maybe on the one side. So you have yourself, you have very, very good riders, professional riders. Like I said, Julian Puffe is helping out. He's a very good guy in the German Championship, second in German Superbike Championship. But we have very normal guys too. So the thing is to get the whole range of riding, because it all has its effects, and of course it's all important.
Thanks for that, Jörg. Well, as I'm sure you can imagine, BMW Motorrad presented many more exciting technology projects across the whole motorcycling spectrum at the recent Tech Day. Among these was a first proper look at the work of art that is the new R18 engine. What do we know about this new engine so far? Not a lot really, when you think about it. We know it's the biggest motorcycle boxer engine ever produced by BMW Motorrad. We know it's going to have a displacement of 1800cc, hence the R18 designation. And we know that it's going to make its series debut in the much anticipated production version that will be launched next year. We also know that the R18 has its roots firmly in BMW Motorrad's past. There's a century of heritage there after all. But you'd be making a mistake if you thought that this big boxer engine is anything but state-of-the-art. So it's great to see this motor up close on the test bench alongside a completely disassembled engine that allowed us to see all the internals. To find out more, I spoke to Kurt Bock, project leader Drivetrain R18.
My name is Kurt Bock. I'm the Drivetrain development project leader for the R18.
So tell me, Kurt, how long has this engine been in development really?
So we finally started with the development in the beginning of 2016. The targets for the R18 development was for sure that we got one thing was look, feel and sound. So that means the look, the layout of the engine has to have the icons of BMW. The feel, you have to have kind of good vibrations, yeah, and an emotional moment when you start the engine. And for sure the sound, it has to be a good sound. And then, at the end, it's a bike. So when you turn the throttle, it should pull, yeah, and just give you a situation of enjoying riding a bike.
So tell me what the emotions were like when you actually started this engine for the first time.
When I started the first time, the engine, it was it's hard to describe. You work quite hard on that kind of project. You put a lot of effort into it. You put a lot of time into it, and then you've got the chance to make the first start in a relevant bike setup. You push the starter button. First of all, you're nervous. Does it move? Does it start? and then when it starts, it was a moment of goosebumps. It's just something special. It's not starting; it's pulling something to life. Yeah.
And we were looking today at a engine built just a couple of weeks ago in Berlin. I mean, as a standalone item, it's a thing of beauty. You must be really proud at how it's turned out.
For me personally, it's my baby. It's really kind of my baby, and I'm absolutely proud when I look at it at the moment. And also have to say thank you to our partner departments, especially the design department, that they've been so hard to us and did not allow us to make so many changes, because mainly as a technician, you firstly want to introduce the best technical solution, and the design department really pushed us and said, no, maybe that's working better, but it's not looking good. And so at the end, that came out, and I'm very proud of it. Yeah.
So there were some real challenges with the design department in terms of looks versus functionality then?
It was not a looks versus functionality. It was more the point of just look. So we would say that you've got this crankcase covers at the top. Yeah? You mainly don't need them. Yeah? And it's quite a hard stuff with tolerances and everything to make that kind of design layouts. And we would like to have it in plastic cover, let's say. Yeah. But then the design said no. Then we said, yeah, but you could also maybe make the color of the plastic cover. And they said, no, we don't make any fakes. So in this project, it means the cylinder head covers look like aluminium, and they are aluminium. The breastplate looks like aluminium, it is aluminium. The crankcase covers are made out of aluminium. Yeah? So that was the fights, what I mean. Yeah?
So give me some facts and figures about the engine in terms of, output, performance, weight, things like that.
So we've got 158 Newton meters at 3,000 RPMs. For riding, the more important thing is that you get a quite flat curve and a wide band you can use. So we've got from 1,800 RPM till 4,000 RPMs, always above 150 Newton meters. So that's the one thing. And we've got, 91 horses, yeah, but you never use them. Yeah. You don't need them.
Okay, so everyone listening is just going to really want to know what it's like to ride on the road. And you're one of the few people who's actually spent quite a bit of time on the road with this bike. Can you just describe, your typical first riding experiences and what's happened since then?
I had the chance to make a test ride through Bavaria on really open roads. And when I came back and the test ride was over, the first thing was I really smiled and I enjoyed it. For sure, I'm maybe not that 100% open-minded because I'm very deep involved into this project. But the main things was for me, it was a pure riding bikes. It was enjoying riding bikes, the landscapes. You are not stressed. You don't care about the other people on the roads. So for me, it's a kind of deceleration. Yeah, and that's what I really, really, really enjoyed, and I hope the customers also will enjoy it when the bikes comes to the market.
And what would you say, looking back overall, what are you most proud of with this project?
Most proud of this project at the moment, I would say, it's that we really achieved to bring an iconic, realistic BMW engine in historic design and layout in an actual bike, and I really like the appearance.
That's the interesting thing about the appearance. It actually looks like something from the past, but actually under the skin, it is state-of-the-art and 100% new, isn't it?
Yeah, it was from the white sheet of paper. So that engine is not that we took a GS engine and just made a nice housing around and finished. So it's really from the white paper. It's a new layout. It's state-of-the-art components, materials. We will introduce with this engine also new technologies which are not available till now on BMW, like a dry single plate clutch with back torque limiter, a slipper clutch. So that's really something which will be first time on the market worldwide. Then also for Phil, for sure, again, the actual noise and pollution and noise and emission regulations, and at the end to hide everything, that you see nothing. So that's an important thing.
And what people are most interested, I think, in this segment is character. How do you engineer character into a brand new bike?
To engineer character, it's quite difficult, because first you have to make the definition of character. Yeah? So they have been basically our marketing department, also involved the design department and the project, so the whole bike project leaders, which basically decided which direction we should go or we have to go. And then at the end, one very important thing was the character. It has to be a boxer engine, and it has to feel like a boxer engine. But then also you have to, for sure, transfer this emotions and character of a boxer engine in the whole emotions and feedback and feeling and character of the bike. And I think they did a quite good job.
They did a fantastic job. Thanks for talking to us, Kurt. It's brilliant.
Yeah, it was a pleasure for me, and great to talk to you and to all your listeners of this podcast. All the best, and I hope you will enjoy when you've got the chance to ride this bike in the future.
Okay, listen up very carefully. Did you hear that? There were two roadsters. One was a 165 horsepower BMW S1000R that revs to around 11,000 with an estimated top speed of around 260 kilometres an hour. The other was an e-roadster prototype that beat it hands down and time again in a drag race. But as much fun as this was, it wasn't really about outright acceleration and top speed. It was more about the fast charging technology and infrastructure that could just revolutionise this industry, as Florian Traub, responsible for pre-development e-mobility, explained to our group of journalists.
We will now go by the bikes to our test track, and there you have the opportunity to drive this electric bike, and also out there I have enough time to explain you. We will do a little race with Holger. He has a S1000R and he tries to follow you.
I will give my very best, I think.
So, go up the bike. Okay, then you can go.
It's a shame I can't show you this, but I can tell you what's happening, and you can obviously hear it behind me. Basically, there's a series of drag races where this e-roadster prototype is being ridden by each of the journalists here. And there's also an S1000R. That's the bike making all the noise, which is trying to keep up in a straight line race, and failing. This one-off e-roadster is seriously quick, 0 to 100 kilometres in under 3 seconds, by the way. What can I tell you about it? I think they've been working on it for a couple of years behind the scenes. It's been built up in the research workshop here at Miramas. As you'd expect, there's loads of shared technology and synergy with the rest of the BMW group. The battery comes from a 5 Series hybrid that's only sold in China. The powertrain's off a 2 Series plug-in hybrid. The dash is from a C Evolution e-scooter. The front forks are from an S1000R, the rear wheels from an R1200R, and the frame, well, that's specially made, of course, to be able to fit the battery. It weighs about 290 kilograms currently, but they're hoping to get the weight down to somewhere between 250 and 260 in the near future. The range, it'll be somewhere between 200 and 300 kilometres, depending on the cycle, of course. But what's important here is the fast charging capacity. I've seen this demo earlier on today, and I can tell you that after this group of 10 journalists has each done their flat-out drag race, the battery capacity of the e-roadster will be at just under 50%. It's been full throttle all the way, remember. Then, Florian will plug the bike into a fast charge unit, which puts somewhere between 40 and 50 kilowatts of energy into the battery. Give the journalist a short presentation about the thermal behaviour of batteries, why battery cooling is crucial for efficient charging speeds, and what the state of play is in Bavaria, at least, regarding fast charge stations. By this time he'll recheck the charge status, and it'll be up somewhere around the 90% mark already, which is seriously impressive. In fact, with this technology you can achieve a charging speed of around 6 kilometres per minute, giving an additional range of 180 kilometres after just half an hour of charge. But of course these fast charge stations are mainly installed near highways, where the majority of cars will be. What about the roads we like to ride? Can we find charging points there? Or are they pretty much restricted to urban and busy areas? I asked Florian to clarify the current status and how that might affect what e-bikes come our way in the future, with urban solutions coming first, and then, maybe, just maybe, bigger bikes?
Let's have a look on the situation of the fast chargers here in Bavaria. We marked it with red dots, and as you can see easily, it's installed mainly at the highway roads. Of course, because the cars need it there, and in urban areas. Here is Munich, there is Nuremberg, there are much charging points, but not that much in the beautiful areas here in the south, in the Alps, also in the Bavarian forest. There are nearly none of them, and this leads us to our opinion that we have to start with electrification first in the urban segment, and after this infrastructure things became better, we can offer our customers bikes like this.
So by now you'll all be aware of the kind of products that will be coming your way soon in terms of electrification and urban mobility. But what about e-mobility of the future? We've all witnessed the futuristic self-balancing BMW Motorrad Vision Next 100 vehicle that was unveiled last year in LA. It's here today and looks just as cool. That was originally part of the BMW Group Future Experience event that transported us to the year 2130. Its rider wore space-age data glasses in place of a helmet. But is this vision really so far away? Let's find out from a couple of the women who work in riding gear development.
So, hi, my name is Camilla. I'm part of the app development team at BMW Motorrad, and my role is research and development within the team.
So what are you going to be showing us here today?
Actually, several things, because I brought today the new app release 2.0 that will be released in about a week, with a lot of exciting new features that were requested, but also some really exciting new features. And the second topic that we brought today is a augmented reality brill. It's an augmented reality glasses that will show a sneak peek into the future of BMW Motorrad and how it could be.
Now I'm looking at these glasses in front of me. What kind of information can be displayed on these glasses?
That's a good question. It's really important to not distract the riders, so we're keeping it down to a minimum. So you really only will see necessary information, like your speed, some navigation information, your gear, but it all can be configured for whatever you need.
How is it that they can work without distracting you? Because by definition, they are in your line of vision. How does that kind of connect with the brain without distracting you from the road ahead?
I think it takes some time to get used to it. The first time it seems very disturbing, but the more you wear it, the more you get used to it. And you don't have to focus away from the road. You're never looking down to your TFT display. And it actually is in line with the vision, and you really don't see it anymore after some time, and you can focus all on the road.
And these kind of glasses, or at least an earlier version of them, that we first saw them when the Vision Next bike was unveiled. So how was the initial response to that concept?
It was quite good. I think people are really curious about it. It's something completely new. I think it's especially exciting because no one does it yet, and people like it. We did a lot of studies already, and people are really positively surprised. At the beginning, they're a bit hesitant about it, but after some time, they start to realize the benefit of it, and yeah, they like it.
And what's the most important information for a rider to actually be beamed to them via these glasses?
Well, that really depends. I was asking that question to a lot of people that we did the studies with, and everyone has a different opinion. There's riders that say like, oh, I don't need to see my speed or my gear because I know it, I feel it. And then there's some that are really happy about it and they like to see the navigation. And I think there's no solution that fits all. And yeah, again, you can configure it. So whatever you need, you can put it there.
And so you mentioned the app earlier and connectivity in general. Do you feel that connectivity is now, via BMW Motorrad, offering similar levels of connectivity that we're used to enjoying in our cars?
It's different. I mean, there's a huge difference between car and motorbikes. We ride motorbikes because we want to have fun, right? We don't have a mobility problem where we want to get from A to B. I mean, sometimes we do, but it's a whole different area that we're in. A lot of the car features that we have in other apps, they're about mobility. But with the motorbike, we have a whole different area to explore. I mean, navigation is a big part of it, but also safety is a part where we can imagine a lot of features. Then there's the entertainment. Some might want to listen to music or make even phone calls. And it's a whole different story. I don't think you can compare it. And yeah, everyone who rides a motorbike will probably share the same opinion.
So when you're talking about version 2.0, what are you bringing us then over and above what we were able to have in the first version?
So we have a couple of new features that we got directly from the App Store comments that we read from all our users. And for example, we have the import and export of routes via a GPX file, which was requested a lot. And also we have a new feature that is route planning with multiple waypoints, which now I can save within the app. And then whenever I decide to ride it, I can select it in the app and go for a ride. And that's quite new. Also, we're bringing some really new exciting features about performance data. So we've been having some performance data already in the vehicle. So when I record my ride, I have a bit of temperature, altitude. But now those data are going to be extended. I'm getting banking angles, I'm getting acceleration, deceleration, and that for the whole track. So if I'm riding on a track or going for a tour in the Alps, I can afterwards really relive this experience. And of course, people want to share their experiences, right? So another feature that is added within this release is the social media sharing. And I'm curious to see the reactions to that.
That's brilliant because, a lot of motorcyclists love statistics, but I find it's really great that you're actually listening to listening to what people are saying, reading the comments, getting the feedback, and then acting on it.
Yeah, it's the most important. I mean, that's what we're there for. We could develop all features, but if no one is using it, it doesn't make any sense, right? We're developing the app for the riders, and we're doing a lot of things actually because of it. We have a dedicated testing group that we're doing with a partner that we have around 160 testers that get the beta version of the app, and they love it. They get to see all the features before, and we get great feedback from it. It's really amazing, and it's a lot of fun to work like this.
Having the connectivity while we're motorcycling, it doesn't take anything away from our riding enjoyment at all. It just adds to it and lends new dimensions that we perhaps didn't even know that were there in the first place.
Exactly. And for those who don't agree, I mean, you can use everything what you want, but if you don't want to, you just don't. And I think once people start to use the whole connectivity and they experience it, they see how much of a benefit it is. And honestly, for me, I could not imagine riding without it anymore, because to me, it's a great help and entertainment.
So the app's here now, we can make use of it right away. The augmented reality glasses, how long do you think before something like that might be finding its way into a serial production?
That's a tough question. I mean, this is definitely a topic that is further away in the future. There's a lot of regulations that need to be taken care of, and who knows what we're going to talk about in half a year, if this is still something people would actually be interested in, or if there's a whole new product that is interesting at the moment. And what I can say is that we keep looking into new products, and we will keep trying to develop prototypes with it, and then we will see what will be the best fitting product to bring to our customers.
That's brilliant. Well, it's never going to be boring. It's as uncertain as the future is. It's an exciting one. So thanks for talking to us, Camilla.
Thank you. It was really nice to talk to you.
In addition to the augmented reality glasses and connectivity apps, we also saw some of the smart connected clothing that transforms according to conditions and requirements. Here to tell us more about it is Ivana Cuc.
So my name is Ivana Cuc. I'm responsible for riders' gear and developing the completely new field of connected riders' gear. So which means riders' gear with an added electronical function.
Okay, so what are you showing us here today exactly? It looks very space age and futuristic.
Yes, it is. So what you can see here is our outfit, our show outfit for the DC Roadster. We showed it already. And what we did here especially is enhance this with some function. And here we wanted to show the lighting function. It's like a backpack. It's magnetic and removable, so you can just remove it easily by the magnetics. See?
Fantastic.
And we added a lighting function here. So the aim is under several and conditions, you can put on some lighting. So I will show you.
The lighting because of increased visibility or safety, or, it's kind of the view from behind?
Yeah, in several use cases. So I will show you one is visibility. So none of us really likes the yellow warning vests, right? we hate it.
Yeah, we're not a big fan of high vis, but again, you can. What I'm looking at here is the high vis color, but that's almost being projected from the backpack.
Exactly. So we have integrated OLED displays, flexible OLED displays, like you know it from the smartphone technology. And here we can switch the modes. So this mode is the visibility mode. So you see a yellow light. We could also put on a warning light, for example, like this one.
Oh, wow, that's fantastic. And that's visible from a long way. So that would be in case of, for example, an accident or if there was a hazard?
Exactly. So in an accident or if another car is driving too close to your bike, so you can the bike can recognize it and then put on the warning light, for example. Or as support for the dynamic brake light also.
And it offers so much more than just a rear tail light on the bike, which people really tend to ignore these days, don't they? So it really increases the visibility to other road users.
Exactly, yeah. So you can also put a logo here, do some advertisement, for example, as you can see now. So here's the BMW logo, which disappears.
The possibilities are endless. Why the name Freddy Bag 014?
It's the name of our designer. So her name is Friederike, and she called this backpack the Freddy Bag.
Got it. That's brilliant. That's fantastic. So that's magnetic. It's removable. The actual rider equipment itself, it doesn't look anything like the existing rider equipment. It almost looks to me like all the elements of protection have disappeared somehow.
Yes, so this was actually the idea behind the complete outfit, to get a fashionable outfit which does not look like a typical rider's gear. So here in this clothes you have the protectors integrated. You can feel them, but you cannot see it really.
Oh yeah, now I can feel them. They weren't apparent at all just from looking at it. So I guess that makes a lot of sense when you're wearing it away from the bike.
Exactly. So in future we think of wearing the clothes also in let's say, not only while driving, but also in other situations. So you can wear it in daily situations, especially the whole rider's equipment for the urban field. So you can see also here another jacket, this one. Here we integrated inductive charging for the phone, for example.
So that's like a wireless charger within your pocket?
Exactly. So.
Wow, I can see that's charging at the moment. It must be difficult, though, to have made that possible to charge all types of different sizes and shapes of phone?
Yeah, exactly it is. So this is the challenge about this charging pocket here. You have to do it elastic so that every size of the smartphone fits into the pocket.
So in order to charge your phone, would that also suggest that the jacket itself has some kind of circuit technology or a battery pack within it?
Yes, it has, in this case, a battery pack, like a power bank.
And I can see here there's something that looks like a light built into the... okay, right. So, well, you better explain exactly what this is. That's lit me up quite brightly.
Yeah. So the idea behind was to integrate a gesture control. So by moving your arm, you could turn on the light, the flashlight, which is integrated into the sleeve of the jacket. So you could use this light, for example, if you're looking for something at night. Yeah, you can use it, or if you need sometimes light at night, then you also have this one here integrated, and it's really nice because you can wash it together with the jacket. So it's washable, water resistant, and so on.
Oh, that's fantastic. And I guess that could also maybe be used as some kind of safety aid, perhaps in the event of a fall or something like that. It could automatically be activated.
Yes, exactly. So it only depends on the programming, which kind of function we give to the light.
So, in your opinion, how far away do you think this kind of clothing might be? Do you think that we could be wearing rider clothing like this in the next 15 years, or is it further into the future than that?
No, I think we can wear it in the next 2 to 3 years. So that's what we are planning.
Oh, wow. So even closer than I'd even imagined.
Exactly.
Well, thank you very, very much for showing us. It's a fascinating glimpse into the near future. I'm just now wondering what the far future is going to bring.
Thanks.
Thanks, Ivana. And thanks, everyone. It's been an amazing insight into a world that's usually closed off to us. One thing's for sure, the rapid pace of digitization is quickly changing the future of motorcycling. As always, though, BMW Motorrad is well prepared for this and is constantly working on technological solutions to ensure that quality, functionality and desirability remain at the highest levels. Fortunately for us brand enthusiasts, BMW Motorrad's technical competence and excellence is underscored by its close cooperation and synergies with all divisions of the BMW Group. All of the people we've spoken to today, and many more behind the scenes, are working hard to ensure that motorcycles are not forgotten in the mobility world of the future. Thanks to the dedication of all those involved in a wide-ranging variety of research and development roles, testing all extreme situations and conceivable scenarios, we can rest assured that BMW Motorrad is leaving no stone unturned in its quest to make motorcycling even safer, so that our individual riding experiences, both today and in the future, are as enjoyable as possible. That's it from Miramas. Hope you enjoyed the insights. Bye for now.